Hello, and welcome to this tutorial stream where we will be making particles using JavaScript. So, stream isn't actually going to start right now, but I thought I should just start anyway. And then just wait until the timer runs out. Which is... Let's get my tabs in order and stuff. So I got 9 minutes till the beginning of the stream. Till then, I am just gonna do something, I guess. Thought it might help get viewers from Twitch and stuff. Get people here before the whole thing starts. But if you're watching this in the future with YouTube or something, then just skip 9 minutes into the video or whatever for the start of the thing. Hopefully I've started by then, haven't started rambling, and well, hopefully people have joined by then. And if nobody's joined, then I guess I'll just delay around a bit longer. Although people might join and I won't be able to see their numbers because I only count people in chat, so I don't know. Whatever. First time I'm doing anything like this. Don't really know what to do. Tap out this on the screen while I wait. Where have you just disappeared to? I have well too many windows open right now. Here's one I prepared earlier. Well, this version of this thing is actually really old. I built this thing years ago. Like 3-4 years ago? 3 years ago? How many years ago? I don't know, some number of years ago, probably. I hate thinking about time. Anyway, yeah, I was planning to do like a really big tutorial stuff, a whole series of tutorials on stuff like this, but tutorials turn out to be really difficult to create. I don't like streaming. So a while ago, I was like, well, why don't I just try streaming the tutorials, rather than doing it pre-recorded. But the problem with this is I rant a lot. There's a reason why the pre-recorded stuff is really hard to do. Just for me, personally. It literally takes me about, I don't know, 2 hours to do a 15-minute video. And that's just recording it. It could take me up to an hour or two just to record it. And then I've also got to edit the whole thing down. Real pain. Anyway. Yeah. So this is actually a much older version. Much more outdated version than the one I'll be making. There's a few little bugs and stuff in this one. Although there are stuff that I'll be doing in this tutorial that will not be in this. I'm going to leave a whole lot up to the viewer for you to mess around and do whatever you want to do, make whatever you want to make. So there's going to be a whole lot of customizability within it, such as the colors of the particles. In this, I have the color dependent on the vector. So the faster it moves, the different the color is. So red is slow and blue is fast. Green in between. And yeah, this little color, the color looks pretty cool. A little bit less chaos in this. I've actually made this really chaotic. I've played around with this particle simulation quite a lot over time. Like it's just so much fun to just play with, poke around, see if you can make different shapes. Like see if you can get a spiral to happen. Spirals are fun. Yeah, see if you can make them move around without any crossing over where the mouse pointer is, or I don't know, stuff like that. How much longer do we have? 5 minutes, okay. Well, anyway, unless somebody comes in and starts talking. Is my chat up? Let me just check that. Yeah, chat seems to be working. Yeah, so while I wait, I'm just going to mess around with... I just created a quick one of this before I started streaming, so I'm running about an hour later than I was expecting to. It took me about an hour to create all of this. Although I did get a little bit distracted with Facebook, but you know, if I've got viewers commenting and stuff like that, then I was just accounting for that time. Let's see if there's any notes I can make on this thing with my terrible spelling. That's the problem. I don't see any places that require notes, because to me, the whole thing is just self-explanatory. As it is with good code. I mean, I could do some basics of code. No, there's no any viewers anyway. Let's wait until viewers before I start actually doing stuff. I was thinking I could do like the basics of code, explain what variables are, and strings, and booleans, and functions, and junk, but there's nobody here to talk about it, and I've just told all the YouTube viewers to skip forward to 9 minutes or whatever it was back then, so nobody may ever see this right now. Everything seems to be pretty self-explanatory. I mean, except for this junk. I don't understand this junk. This magical math stuff that I just googled years and years ago. Never learnt it. I'm terrible with math. Like, as soon as you have stuff like sine, I'm lost. I have no clue how sine works. I mean, I have a basic understanding of sort of how it works, but I don't understand how it works, like how it literally gets that result or anything. And I have no clue what that thing is. I've seen many things about it. I've since forgotten them. So I'm probably going to be skipping past this part of the math stuff a bit. I'll just sort of explain what it does, like, you know, that you get the two things, you minus them, you times them together to get the square of both axes, and then you get square root of the combined squares. And that will get you distance. How it gets you distance, I have no clue, but it does what it does. Where's my timer going? I don't keep tabbing away from my timer. Might hear a bit of a building going on in the background as well. That's because there's a building going on in the background. Surprisingly. Hopefully they don't bang on chunks of metal or do too much sawing and stuff. It's a pretty cool place. The whole thing's made. Hey, people are here. Oh, hello. Yep, I'm just rambling while I wait for the start of the stream. All is well. The one person who wants this is here. Shout out to my sponsor, Twitch Fans Pokemon, sponsoring the stream. Yeah. Space there. Well, it's about 105 lines long. Pretty simple. Hey, hello, DevMew. I am just preparing for the tutorial stream, so I won't be doing my Doom thingy today. Or at least not right now, I might be doing it later. I doubt it though. I've been playing a whole lot of Diablo. Almost done. Anyway, 2 minutes or a minute and a half, roundabout, until the stream starts. I'm just rambling until then. Anything else for me to ramble about? Let's go to Facebook notifications. Get the particles back on the stream. Where'd the chat go? Damn it. Okay. I'll be doing this. So I'll be doing this as a tutorial sort of stream thing. It's only about 115 lines of code. So it's like a floppy pancake. Let's get it to spread out a bit. I have no clue. Some amount of particles. Probably like 50,000, let's say. I don't know. It used to be 50. It used to be 2,000, but I upped it a while ago. I don't know what to. I integrated this into my API to see if I got better performance from it. That is now my very, very old API, back when my lag system. Yeah, back when I used to use divs. I'm entirely using the canvas now for all of my work. This thing is just not wanting to spread out, is it? Maybe if I do it, actually think about what I'm doing. I should get it spread out a bit. Yeah, any minute now. 6 seconds. 5, 4, 3, 2, 1. Okay, just stop beeping at me now. Okay, so let's start this thing. Get my tabs back in order. I probably want to bring up Twitch so I could put... nobody will be probably watching. Never mind. I was going to just like put some code into Twitch or something like that if I needed to, but I doubt anybody's going to be actually viewing from the Twitch side. Maybe just from the future. Damn it. Just from the future. Damn it. I have way too many windows. I lost the chat again. There we go. Oh. Oh. Good night. It's a pretty easy thing to do. Don't really need much luck. Oh yeah, that's right. I don't need to upload files. Oh, it's so much simpler. Okay, let's start this thing. So, what have we got? I was going to clean this up a little bit. I'm not sure if I should just... let's just keep this part here. So this is all my HTML stuff. So first off, we got the HTML tag. This just tells it it's a HTML file there and there. If it's your first time using Notepad++, this will probably all look gray and completely different. If you want it to look like mine, the way you do that is by going, I think, Settings, Style, Config, and then I use the Obsidian theme with some minor adjustments that I made on my own to make it look a little bit more like the default theme. And you just press F11 to full screen the whole thing, so that's that. Yeah, everything will be all gray. All this text will just sort of be all the same color by default because it will automatically think that it's just a .txt file. So the first thing you're going to want to do is save the project. So you could just press Ctrl+S to save, the quick save button, and then just save it as something.html, wherever you want it to be. You could literally just type in .html to the end of the name. You don't actually have to select it from the drop-down list. I've already saved this one, so I can't really show you. Create a new one. But you guys probably can't see much anyway. You got to type something in before you can save it. But yeah, you just type in whatever.html and then save. That's all you need to do. It'll automatically detect this then as a HTML file, and you'll get syntax highlighting, which makes it go all pretty and colored. Okay, so the first thing we got here is the HTML tags. We got the opening one there and the closing one there. So this means it's a HTML page, and HTML will understand this. The next thing we got is head, which inside the head we have the title. So the title is... not sure how much of a beginner sort of style I should have this stream cater to. It's a little bit annoying. I also don't really know which style I should be teaching, and I'm going to be doing a style of teaching which I don't really have a name for, but I'm going to call it like a destructive style. I will be coding in mistakes and problems that I know about, and then showing you how to get around those things and fix them. So I'll be coding as if I don't know what I'm doing, and well, I have a general idea of what I'm doing, but then don't know what to do next. I'm only focused at the problem at hand. Okay, I guess that's the problem at hand teaching style. Let's call it that. Except for this part, because, you know, I can't be bothered typing this in every single time, and it's nice and simple. So yeah, they got the end of the head, so the head starts there, it ends over here. We have the title. The title is this. So you can see it says particles with a smiley face. Whatever I type into here, apples... Ctrl+S to save. You could just automatically press save. Open your HTML file in your browser of choice. You can either drag it into your browser, just make a new tab, drag it in onto the new tab, or you could just double click it and it'll open up with your default browser. I have many different browsers, so my default browser is one I don't use. Little trick. If you're always getting those little viruses around the place that install tools into your browser or redirect you to places and put ads on pages, all that sort of junk. It's really annoying. Just set your default browser to something you don't use, because they will just install themselves onto your default browser, generally. That's why I do that. Anyway, I'm going to try not to rant so much. Already failing. Anyway, so we could just refresh this page, and it now says apples, because we put in apples. So just undo that, back to particles, save, and refresh. There you go. You don't have to worry about dragging the file across or opening it every single time. You can simply refresh the page. This could be a little bit of a problem sometimes later on when you're programming with more complicated stuff. Say if you're using multiple files instead of just one single one. Say like what I'm doing in my... Ooh, that goes really terrible when I resize. This is a project that I'm working on currently where I am using many different files that are all being imported into this main one. When you do that, simply refreshing the page could have some problems. But there's ways around that. You could just Google them, I suppose. I'd probably get into them a bit more later. Oh, gotta stop ranting. Anyway, so yeah, we got the head, then we got the body. So the body is where you usually put your content. If you've ever used HTML stuff before, this is usually where you will put your website, or your divs and containers or buttons and whatever, what have yous. We will just be using a canvas, so that's all we need. Then we have script, and script is where we will be doing the code. And that's just the end of the HTML file. So first up, we got the body. So I like to make the body style. So the style is style. I'm going to explain that. We want overflow hidden. So what that's going to do is it's going to remove scroll bars from your page. So if you put too much text in your page or something like that, usually scroll bars will appear. This will get rid of those because we don't want those. Next we have the margins. So by default, you will have a margin to your page, which means any content you put in here will be offset by something like, I don't know, 6 pixels or something, or 7 pixels from the top and the side. I don't really know the exact amount. So we want to clear that. We want our content to be all the way up to the very corner of the page, as far as it goes. And then width 100%. I think the width... What's the height, isn't it? I don't know, I might have something wrong there. I might have to do this with height and width, but I remember problems with that long ago. This is sort of stuff that I just have standard in all of my projects, which I've since forgotten how it works. I removed a large chunk of extra stuff I may have accidentally... No, never mind. Stop, I want this one. Yeah, so that one just used the width. This one worked perfectly fine. I did a test run before I started. Anyway, so then we got a canvas. The canvas is like a canvas. It is what it sounds like. This is where we will be drawing or rendering or whatever, all of the stuff that we want to be displayed on the page, all of the particles moving around. Not really the stuff we just, I mean, whatever. So the first thing we have is the ID, and our ID is canvas. You can name this whatever you want it to be, but canvas is canvas, so let's call it a canvas. Next we have the width and the height. The width and the height, also don't ask me why these are yellow. They're yellow because that text is yellow, I guess. I don't know, some sort of HTML context sensitive stuff. But then this isn't yellow, so you do you. The width and the height are not the width and the height of the canvas. They are the resolution of the canvas. So if you say the canvas resolution is like 600 by 600, but then also has the style width and height, which I'm not setting by default, to be the full screen of the page, your thing will look like Doom, because I'm pretty sure the resolution of Doom was something like 600 by 600. Anyway, it'll still be the full screen of the page. Your pixels that you have on the canvas will just be really big. So you can have some cool effects with that, but I will be coding some dynamic stuff later on to dynamically resize these default values to be a one-to-one resolution of your screen. We also will have style width to the height, which I just don't have here by default. I don't actually know what the default size of them is. It's probably like 150 by 150 or something like that, who knows. And a background color, which I have as white. You know what, we can see what's what by changing the background color and then refreshing this. Okay, so there's my canvas. I just changed its color, and there it is, with a resolution of 300 by 300. Maybe by default it goes off this, I don't know. I shouldn't really be messing around with stuff. Yeah, look at that, okay. So it's default width and style width and height are whatever the default resolution is, so 1-to-1 pixels. Yeah, we won't worry too much about that. We set them both anyway. It's very hard to do this when I don't have feedback from viewers to know if anybody's got any questions. Anyway, so here's another thing. I'll try to not say so much. We have indenting. Indenting is what you call these tabs we got around the place. Also, Notepad++, if you haven't used it before, has this really cool highlighting mode thing. So if I double click a word, it will highlight any other words that are the same word. It's really great. But when I highlight a tab, it highlights all the other tabs. But anyway, so, or indent, or you do an indent by pressing tab on the keyboard, and it will move it. It'll basically add 4 spaces, which isn't technically 4 spaces, it's 1 space that is as long as 4 spaces, which is very important to know if you plan to do certain things, like using Java. This is JavaScript. If you're using Python, Python is a lot like JavaScript, but it's slightly different, and it treats tabs as 4 spaces instead of 1 space that's 4 long. So, yeah, there's the difference between a tab and a space. Anyway, so usually when you're programming, you indent stuff according to levels it's in. So all of this stuff is inside of the HTML tag, and this is inside of the head tag. And this allows you to really quickly and easily see what is inside of what. If the whole thing was all collapsed down to one line, then you've got to look through one line at a time to find, like, where does HTML close? Ah, there it is. Or something like that. It's just easier on the eyes. More readability. Anyway, so let's get to programming. So the first thing we want to do is let's make a square render on the screen at a location that we've set it to, and just an arbitrary size. So we want a particle. This is probably going to take longer than an hour. Because I could do it, but then I'm going to have to be I'm trying to do it in a way that I don't have to say, don't worry about this right now, we'll come back to that later. I don't want to have to ever say that. But that's going to be really extending the time of this thing. Anyway, rambling. Just get my stream up so I can actually see how long I've been going for. Okay, which I don't know, it says 22 minutes, but that was... whatever. Okay, variables. So, var. The first thing I will say is var. Var is declaring a global-ish sort of variable in this case. Global variables and local variables are a little bit confusing. I haven't actually done a full amount... 12 minutes, okay. I haven't actually done a full amount of research into these things. I just know them enough for what I use them for, which terrible to be saying. I probably shouldn't be saying that. I can go back to things, but I try not to say don't worry about things. Because I don't like... When I was learning programming, I hated having people say that, because it's like, all I could think about from then on is, why did you do this? And I have to keep watching, and all I'm thinking, but is this important? Is it not important? Why did you put it there? What happens if I remove it? Like, all that sort of stuff. Anyway, rambling. So we want to declare a variable. So let's say just a nice simple location and size, I guess. These are global, or what I'm going to call global variables. So I'm going to put capital capital letters at the start of the words. I like to do that with my global variables. Global variables have a capital letter. Local variables are all lowercase. And then with my functions, I like to have 2 words. The first word lowercase, the second word uppercase. Generally, I always try to have exactly 2 words, no more, no less. If you can't describe your function in 2 words, you probably should split it up into multiple functions. Yeah. And that's just the way I standardize things. So let's have a location. Our location will just be, I don't know, the size of our canvas right now is 300 by 300, so let's say it's, I don't know, 50 by 50. So we want this to be 50 pixels across from the right and 50 pixels down from the top. 0, 0 is the top left. That's just the way the HTML canvas stuff does it. Don't ask me why. And the size will be equal to, let's just go with 50. So we want to have a box that is 50 in size and starts at 50 by 50 on the screen. Okay, so now I guess we'll try not to say R and but whatever. Damn it! It's hard to hurry and not do that. So let's render stuff on the canvas. To render stuff on the canvas, we need to get the canvas. So make a new variable, canvas. Let's get our canvas and store it as a variable. So we only have to do this once, so we don't have to type in the whole thing every time. So to get the canvas from the HTML side and reference it within the programming side, or the JavaScript side, code side, script side, whatever you want to call it, we say document dot lowercase get element by ID. So what this function does is we have a document, which is basically everything inside of the HTML tags, I think. And then we're getting an element, which our canvas is an element, by ID. So our canvas ID is canvas. So we put that in there. And now this is essentially that. All of the information that we have about this. So using this, we can alter any property about this. There we go. So now let's get a thing to render on it. So we want to say canvas.get context. Who knows if I'm spelling things correctly? I'm terrible at spelling. 2D. So this will get the 2D context of the canvas. I don't actually know exactly what this means. I guess this just gives us a whole lot of tools, so our paintbrushes and things, if you think about it like a literal canvas. There are other things you could type into here other than 2D. As far as I know, 3D is not one of them. You could get the... I keep saying it. You can get the WebGL if you use WebGL for whatever you want. The context WebGL would be how you get that, or WebGL2 if you're using WebGL2. Other than that, I don't know what else you can get from this, and I don't really worry about it. So don't worry about it. So let's draw something on the canvas. We get the canvas context 2D, and we want to store that as a variable var ctx is usually the default you would see for this. So W3 Schools is a really great place for looking for tutorials and information. Well, not really tutorial. I've never looked at tutorials there, but information about programming, what things are, how you use them. So you can look at this getContext.2D and get a whole lot more information about this than I could probably tell you because I never actually looked it up. Well, in depth. So yeah, usually all of their examples, they will say CTX when referring to the canvas context 2D. So I assume CTX just stands for context. With our canvas context, we can now use this to draw stuff onto the canvas. Hello, people who are joining. So what do we want to draw? I'm going to copy some stuff from this one that I prepared earlier so I know what's going on. This is basically what it's going to look like at the end. So we need to do this. So we want to create a rectangle on the screen, and style is what the rectangle is going to look like. So we want it to have an RGB value of whatever, let's say red, because why not? RGBA, so that's the red channel, green, blue, and alpha. And for whatever reason, alpha is from 0 to 1, where RGB is from 0 to 255. Don't ask why, that's just the way they decided to do it. It's terrible, and I think it actually causes a few problems around the place sometimes, but we'll worry about those. I'll probably mention them later on when they happen. If they happen. Or maybe I won't. I probably will. Okay, so this is telling us that the cube or square we are about to render will be of this color. And we want to put this square where we said we wanted to put it. So we want to put it at location 0, location 1. So this will be the top right of the square, and we want its size to be size by size. So it'll go to this location, and then it will offset by that to get the opposite corner, and then it will create a square that is 50 by 50, and then size by size to get the square. There we go. So you should now be able to save this and go back over to where we're running it. Refresh that. We got a red square in this terrible, blinding purple background. This looks garbage on my screen. Let's make it blue. There we are. So we got a red square and a blue square. Okay. So now let's make it so this is full screen and not this little area up here. To do that, we will create a function. So, whoop, function. Once you type in a word once, it will remember as the context things, if that's the right word. So if I say fun, it comes up with function. So I never have to spell any more of the word than that, and you can just use the arrow keys and enter to do whichever thing you want. Press escape if you don't want that box to be there, or for it to go away It will come back up when you press the next letter though. So we want to create a function. This function is to resize screen. I like to call it resize screen. It's not literally resizing the screen, but it's the screen in context to what we are using within the browser. Not the literal browser or your... Why am I explaining that? Obviously. Sorry. Like, not your actual desktop PC. It's like screen, resize screen to like 10K. Yeah, sure. Suddenly a 10K screen pops up on your desk. Anyway, so we want a resize screen function. And this function will then mess with our canvas. So the reason why we said canvas is this, and not just CTX by adding this extra part to the end of there, is because we do actually need canvas and CTX separately. I could define another one that says CTX. In fact, let's actually do that. Let's just move this up there. And then put a capital C there. I don't like that because I'm used to having this as a lowercase c. But whatever. There we go. So CTX. Then we never have to worry about that again. So we want to resize the screen. To resize it, we've got to be using canvas. So canvas dot. So again, canvas. Well, not again. I haven't explained it yet. Canvas is. What's this? Okay. Sorry, I missed your message. Let me just refresh my chat. Maybe it bugged out. Canvas dot, so yeah, canvas, you can think of the canvas like an object. So we're going inside of the canvas to find its properties, and we want the style. So you have the canvas, and inside the canvas we have the style, and that's equal to a whole lot of things. We want the width of that, and we want to change it. So just like we would have done width up here, if I had done width up here, let's just do a width up here to show what that is. So to do a width in here, you would say width. My screen just flash? Whatever. Width and then colon. Let's just say 100px. And then one of those at the end. So that would set the width of the canvas to 100px. If we had a percentage there, it would be 100%. Basically, we've got to do the same thing down here. So width, and then instead of the colon, we have equals. So we would say this as a string. It doesn't have to be a string because it's numbers to start off with. But we could say 100px, and that would redefine that. But because these are numbers, we could just say that outside of here and plus that. So this will convert 100 into a string and then add px to the end of it. And this is the whole thing with JavaScript that's so funny to watch people sort of lose it over. JavaScript is a very, very loose programming language which allows you to do this. Like, if you wanted to do this within C, you would be insane. Like, why would you try to do this? There's no reason for this, you know. But in JavaScript, this is a really awesome thing. It gets a little bit confusing if I did something like this. Like, would it convert 100 to a string and this would be 1005? Or would it add 5 to 100 and it would be 105? I believe this would actually be 105 if you were to run this. And that's where things get a little bit confusing, because plus is both concatenate and add if it's adding numbers together. Concatenate just means join two things together. Okay. px. So there we go. We could now say this is 100px. But we want it to be the full size of the page. To make it the full size of the page, we want to say another one of these document things, but not document.get. We want document.body. And I don't really remember why exactly we can just say body, but I think it's because body is body. It's just one level deep. If we say head, it would be head. If we said script, it would probably be the script, which would be funny, because you could get the script from within the script and cause infinite loops, probably. Probably not. I don't know. Never tried it. Maybe there is a way, but who knows. So we want the body dot offset. Offset width. So the offset width is like the style. We could also say body.style.width, but the width would come back with something like 100% probably. or it would come back with something.px. So by doing offset width, this gives us the literal value that the width is currently at, without the px being there. So this is exactly how many pixels across the screen the width is. Yeah, and let's sort of skip a step and say size is equal to the offset width. So this is a local one, lowercase. Offset width and offset height. So the other thing to notice about using the same thing with if I did style, sometimes you have things like background color. Background color is 2 words. You don't actually say background color like this if you were trying to reference it with the style. You would say background in lowercase and then uppercase C for color. All one word, no dash between it or anything like that. So it would look like this. This is how you'll get the background color through the style using JavaScript. So the same thing with this, offset and then the height with the capital H for height because it's the second word. It's just the way it works. I don't think I've ever tried it with something with a 3rd word. I don't know if there has anything with 3 words, but it'll probably be another capital letter for that. Oh yeah. It'd probably be the same sort of formatting as this. So I think this is called camel case, where the first one's lowercase and every other one's uppercase. So it's like the humps on a camel. I don't know. That's what teachers used to say. So yeah, now we have this variable size. Size is the size of the screen. It's the width and the height. And we can just say size 0 plus px and size 1 for the height. I hate the word height. It's like Hegit. Few more things to note. Control D is how I duplicate a line, so that's a handy thing to do. Just if you're wondering how I'm doing that so quickly. Another thing to know... Nope, I forgot what the other thing I was about to say was. Oh yes, no. It's a good habit to copy every word you can, because you don't have to be good at spelling to be able to program. You also don't have to be good at math. Google is good at math. Computers are good at math. It's like the difference between being the student that gives that works out the math problems and a teacher that gives you the math problems. The teacher doesn't have to know the answer. As long as the majority of the class get the same answer, you can probably pretty much assume that it is the correct answer. They don't actually have to check it out. But computers generally will always get the correct answer. So you don't have to be good at math. For everything else, there's Google. You just Google math formulas. But yeah, when you're spelling, occasionally you will do spelling mistakes. Like you will accidentally forget to do a capital letter sometimes. So it's a great habit to just literally copy-paste words as you need them. If they're just easy references of them on the screen. You just never really have that problem if you do that. Unless you... No, you should never have the problem if you copy-paste. Anyway, so yeah, we'll get the screen size. We set that to be the width and the height, and there we go. So this is our Resize Screen function, and we want to run it. So let's put it down here. One actual other thing we need to do is also resize this width. So we could just pretty much remove that and remove the .px part, because as we see here, it's just 300, not 300.px. So we can say width and height is equal to size 0 and size 1. So this is going to resize the width, which is the resolution, width and height, and also the style width and height to be the same. And that should be full screened to the size of the body, and the body should be 100% of the page without any margin or overflow. Okay. So we should be able to save that and run it. There we go. Everything's blue now. Although you will notice that the box has disappeared. Well, there's no red box up here. So when code runs, as always, it goes from top to bottom. So the first thing we're doing is getting canvas, the CTX location size. Then we are getting that style and putting the red square down. Then we are creating this function but not running it. So it's just coming into existence, but it doesn't care about any internal stuff. Then we are running it. So now we're going through each line at a time, and then we go back down to after here. So when we resize the canvas, it actually clears it. Everything that was there is now no longer there, and that's why our box disappears. if we were to move this up here, you would think that might fix the problem. But this will cause another problem because it's trying to run a function that it doesn't know about. It came down, it found this function, it says run it, and it's like, what function? Doesn't know of its existence until after here. So we could just move this whole function up there to do that, but instead of doing that, let's move this down. You can highlight the whole line by clicking on the numbers on the side of the page. So, now if we do it, our little red square should be back. There we are. Okay, and again, we can adjust the location of the square by adding numbers here. This will move it down. There we are. And we can move it across. Left. Okay. So now, what do we want to do? We want this cube to move over time. This is a problem. Because... should I do that? Yeah, let's go into that. We don't have any time. We have one frame. It goes from top to bottom and then stops. There's nothing more for it to do. So we need to get it so it can loop this stuff over and over again. But we don't want it to just constantly loop it, as some people might do. If anybody's had any experience in this before, you might see pretty much everyone tell you to use request animation frame. The request animation frame thing basically just says, as soon as you finish running all code, run this. And that will basically be looping all of our code as soon as, I assume, physically possible for the hardware to do. I don't actually like doing this, because that basically means your browser is going to be running at 100% the entire time it can be. And, you know, if it doesn't need to change, it doesn't need to change. So what's the point of doing it? So what I like to do is use this. I'm just going to copy it. It's not really that long. So I like to call this function the frame offset. Well, actually, no, I don't. I never like to call it. I like to call it render check usually, but this time I'm calling it the frame offset. So this is going to be calling it. This is going to be offsetting time by one frame or something like that. It's going to be re-rendering every unit of time that we have, our frame rate. And let's just get rid of the stuff that we don't... Why did you do that? Oh, the scroll bar appearing and disappearing, probably. We just need this part here. So what this is doing is we are creating a function. So there's more than one way you can create a function. One way is saying function, whatever. This is a global function. We could access this at any time, anywhere. But this is a local function. This function only exists within here. As soon as we drop outside of here, we can't call fun anymore because it doesn't know of its existence anymore. So we have a function which we are storing in a variable called fun. You could think of functions as variables. They're variables of code rather than variables of numbers and letters and stuff. So yeah, we got this function, and this function is literally going to be running the thing that ran the function. So this is our loop. But we don't want it to be running instantly because this would loop forever and never actually render anything. Because all of this rendering stuff happens after our code has finished, as far as I understand. So if our code never finishes running, we will never see anything actually display on the screen. So we need to have it pause. We need to have it wait for a moment before running the code again. And that's what this set timeout is. Set timeout waits for a timeout and then sets a thing to run, let's say. So it sets a function to run after the timeout has happened, after it's waited that amount of time. So this is measured in milliseconds. 1000 milliseconds is 1 second. And we want to divide that by whatever frame rate we're running at. So let's create a new variable. Scroll bars are back, screen flashed again. I like to run at 24 FPS. My screen recording stuff doesn't actually run faster than 24 FPS, so let's just say it's running at 24 FPS. You can have it to be whatever you want it to be. But this does have a limit in how quick it can, like how long it can wait. It's got a minimum amount of time that it must wait, and you can't set it any lower than that. What that time is depends on your browser, on your operating system, who knows what, alignments of the stars, I don't know. You could probably research a whole lot of stuff to figure out exactly what it is, but it's about 10 milliseconds. That's as low as it goes, pretty much. I think it's 10 milliseconds? 10 to 5? I don't know. So you could put 0 in here and it still won't run instantly. It'll still wait that amount of time. So 24 divided by 1000 is, calculator up, 1000, I always say them backwards. 1000 divided by 24 is 41. So this is going to wait 41 about milliseconds before it runs the next frame. You could also work this out the other way. So if I said 41 divided, I did that backwards, didn't I? 1000 divided by 41 equals 24. You know, I didn't have the floating point stuff, so. And that really confuses me. I don't know about anybody else, but this confuses me how I can divide 1000 by a number, and then I can divide that number by 1000 to return it back to its original number. That just messes with my head. I don't know why. I suck at math, as I say. But that's a thing you can do. So 1000 divided by the FPS gives you how many milliseconds? 1000 divided by however many milliseconds gives you the FPS. Anyway, but that's much, much greater than whatever we want. So we could actually just check that. Where'd my calculator go? I just put it, didn't I? So 1000 was going to be 100. So about 100 FPS is the most that your browser can support with the frame rate offset, set timeout thing, which I believe is actually faster than the request animation rate frame. I did a little bit of testing with it a while ago, and I actually like this system a whole lot better. And this is why I use it. Anyway. I'm rambling so much. This is definitely going to take over an hour. It's almost been an hour already. Oh my god. Whatever. Kitty cat. Stop distracting me, kitty. She keeps walking over and just staring at me. Yes, kitty cat. I know of your existence. Okay. So what do we got next? So we now need to get this thing to run. Indent that. So this will create this function and then tell it to run. This will then create this subfunction or local function, create the timeout that will run this function after that amount of time. So after however many milliseconds, 41 milliseconds or whatever it was, it will then run this function, which then runs this function, which then starts the whole thing over again. So what we want to do is say render. Render, what did I call it? Render frame. So we want a new function in here that will render the frame whenever this thing gets done. Wait, render the next frame. Wait, render the next frame. Okay, so we need a new function. Now let's put that above here. What's wrong? Damn it. Function, render frame. And we want to put this inside of it. Okay. So this is our frame that's going to be rendered. We should be able to save and check this, and we will see absolutely no difference at all, because we haven't told anything to happen. A nice simple test to just see if something is happening, we can just say location 0 plus equals 1. Or we could just say plus plus. There we are. We got our cube looking like it's growing. The cube is not actually changing shape here. It's moving across the screen. But whatever was on the screen before putting down this, rendering this new cube, is still there. So it's literally drawing a cube onto the canvas as if you were doing it with paint. You're just got like a tool that is a square. I keep calling it a cube. You got a square and you're just stamping it onto the canvas. You're moving across by whatever a pixel is, stamping it back down, stamping it back down. So we want to clear our canvas before stamping it back down. And to do that, there's many different ways we can do that. One way is resizing our canvas. Another way is by using a thing for literally clearing the canvas. And the way that I like to do it is by using a square, a rectangle. And we're going to tell this rectangle to just go from 0, 0, so the top of the page, and we want it to just be the full size of the page, which we have defined locally here. We could literally just copy that and put it down here and then say size. Or we could say screen size. capital S. So let's create a new variable called screen size. Screen size 0, screen size 1. And let's just dump that to the list of stuff. Screen size is just whatever, we don't care what it is initially. Because one of the first things that happened is we resized the screen. So let's just dump that in there, and we don't need it to be varred anymore. So now this global variable is going to be whatever the screen size is when we resize that screen initially. And there we are. So if I run this now, it didn't work. What did I do wrong? I made it blue. It should be, no, this is red. It should be showing a red screen right now. Okay, debugging. If you press Control, Shift, and I, which is default in most browsers, that will pop open this console, which should look like that by default. You just click on console. Whatever browser you're using will have something along the lines of this. You can also use whatever options and then possibly more tools, developer tools. So it could be like that to access this thing, or who knows what. You could just Google how to open the console on whatever browser you're using. And then, yeah, look at console. So this says that size is not defined, 19 of particle sim. So if we go to line 19, size is not defined. Yep. So we're using Resize Screen now. Oh, screen size now. There we go. Refresh. No errors, screen is red. That's because we made that red. So let's make this blue again. RGB. Refresh. And there we go. Now we've got our cube, move it across the screen slowly. There's another cool thing you can do with this, which is why I use this method, which is you can mess with the alpha. So this is basically drawing over the entire screen with a blue thing. And then, so stamping a blue square on the screen, stamping your red square. Blue square, red square, blue square, red square. And we could use opacity. We could use the alpha. So you can just say point whatever, or you could say 0 point whatever, it doesn't care. So let's just set the alpha to be 0.3. That's just the value I like to use. And let's refresh this. So you may notice the cube now has a bit of a trail to it. You probably actually can't see that that well on the stream. There we go. It's a bit more obvious now. Okay. So yeah, we got this little bit of a motion blur to it. But you'll also notice it's leaving like a squidgy mark on the screen. This is that problem I was saying with alpha being 0.1. Even though it's 0.1, it's still within the range of 255, I believe. So 255 as a percentage and then grabbing 1% of that will be a float. It will not be an integer. And I think it's because of that it can't properly fill in the alpha. It's always got to have a little bit left that it didn't draw over. And that leaves the smudgy mark. So you just have to experiment with it to find a number that doesn't give you the smudgy mark. Unless you like the smudgy mark, it is sort of cool. It'll also show up more or less depending on the screen colors you actually have. So I don't even know if anybody could have seen that smudgy mark just then, because I got a screen with really high color depth. That's why I bought the screen. But yeah, people on lower end monitors and stuff may not have been able to see that smudgy mark, or it may have been even more exaggerated. Anyway, you're just got to keep that in mind. So we got a cube moving, we got the frame rate, we got the canvas being cleared, and then new stuff being drawn. Next problem. Wait, no, let's not worry about that till later. Next problem, what do we want now? We want it to move... No, let's make many particles all over the screen. Yes. Let's cover the screen of particles. Okay, so to cover the screen of particles, we are going to basically toss out this system and do something completely different. We want to have particles, and we want an array of particles, so we can dynamically add and remove them as needed. So for p equals 0, p is less than amount, so however many particles we want, p plus plus. Cat wants attention again. Come on. Gave her a whole lot of attention before I started streaming, so she wouldn't do this, but she came back anyway. Maybe I gave her too much attention. Okay, so what about we got? Please don't stare at me, kitty. Just move away. Whoa, kitty. She was walking away while staring at me and tripped over a thing I have on the ground. So we wanted amount of particles. Let's say we have 100 particles. Let's spawn in 100 particles. So this is p equals 0, while p is less than 100, p plus plus. So p will keep increasing until it is equal to or greater than 100, and then this loop will stop. So we want to give our particles a location, a size, and also more information, which I will be giving it. So we want all of this to be stored in object form. So let's say a data or data, whichever you like. Data is equal to an object. Data.loc equals wherever we want our particle to be. Size is the size of our particle. But I'm actually going to change this now. Instead of, am I? No, let's keep it as size. Never mind. We want the size of the particle. We also want a vector, and we want a color. The color of our particle. All of these things are arrays, so our location is going to be something, but if we just type in a number here, every particle is going to be put in the same location, so there's not really much point to it. We could use p, because p is a number that is changing for each of the particles to offset the location by a certain amount. Like we could do, I don't know, probably like sine p or something, I don't know, fun stuff like that. But let's just use a random number. So, math.random. So this will create a random number between 0 and 1, which isn't really that helpful for us right now. I mean, what are you going to do with half of a pixel? It's not really going to be offsetting it at all. So we want to do that, and then we want to times it up to a number that we can actually use. And the numbers we want to use is, we want to randomly place this somewhere within the size of the screen. So we need to have our screen size before we can spawn in the particles. We could just move this down. Wait, how did I do this before? Oh yes, I put it in the thing. Okay. So sure, let's just move this down for now. We'll be moving it somewhere completely different later on. So after the screen has been resized, then we want to spawn in our particles. As that amount of particles, and we want to put them somewhere within the screen. So screen size 0 for the X and 1 for the Y. So now our particles would be spawned somewhere randomly within the screen. Let's just give them all the same size of something like, I don't know, 30 by 30. Let's give them a vector of 1, sure, 1 in the Y. And the color of red. So this is the way I like to be doing colors if I'm doing it in a variable sort of a way, like we currently am. So currently am, whatever. So RGBA, same as I always use. This is what I like to do. And there we go. So we're going to have 100 particles be spawned, each with a random location, size of that, vector of that, the color of that. Now, we also need to add it into some place which we can then reference. So that's our particles. Let's move that up. So this array is going to contain all the particles we have in our scene. So particles.push data. So each index is going to be an object that is data with all of our information. Okay. Now we have other problems. Next problem that we have is we can now no longer render this thing because we don't have this location and size. It's not a global variable anymore because we moved it in place of the array system. So we need to fix that. To fix that, we're going to say for let's say particle. Hello. I'm doing my tutorial stream today. Wait, it didn't say you just joined. Oh. Did I see it? Whatever. I don't remember if I noticed the chat when he said something. So what are we doing? Particle. for particle in particles. So this type of loop is going to loop through every index of particles, and particle will be whatever that index is called. In the case of an array, particle will just be a number from 0 to 100, 0 to 99 in this case. 0 being the first index and 99 being the last index. So we actually want the data itself, so we can say particle equals particles particle. So this particle in particular is what we want, and there's the data. We don't have to say var before this because it's already defined right there. Okay, so now we can say particle dot location, particle dot location, particle dot size, 0 and 1. And there we go. In fact, size doesn't actually really need to be that, because generally we're going to keep everything the same. Well, I'm going to keep everything the same shape. You guys could do different sized particles and different axes, but I'm just going to have it so it's just a constant square. And with that, I don't need to do the array part, because this bit of data is no longer an array. So again, we're looping through the particles. Particle is a number that is the index that we are wanting. So then we are redefining particle to be that index in particular. So at this point, this is exactly the same as saying data up here. So we have data.location, particle.location. Location is an array with 2 places, x and y. So we want the x and y axis, or location in that array, which is index 0 and 1. I always do index 0 being x and 1 being y. It's just standardized systems. It always helps to standardize your systems. It's a lot less confusing that way. Like, you should never try to offset indexes. It's a thing that lots of noobs do, and, you know, go ahead and do it if you want to do it, but eventually you will learn not to do it. Which is, an index starts at 0, while a length starts at 1. If you have one thing, the first thing is the first thing. But when you have the indexes, the first thing is 0. 0 is 1. And a lot of people will try to offset that to make it so instead of using 0, you use 1. I suggest never doing that. I mean, you can do it if you want, but you will quickly learn that you're constantly getting confused about stuff, unless you're like that guy that's like, oh, I am getting used to this, this is great, I don't know why everybody thinks that. You just haven't done it for long enough. You will turn back around. Luckily, it's easier to unlearn than it is to learn it. Anyway, so there we go. We got our location and we got our size. And if all is right with the world, we should now have an error. Math is not defined, because math has an uppercase letter. I have no clue why it does that, but that's just what it wants to do. Math, uppercase, random, lowercase. There is one other exception to this rule, but yeah, there we go. 100 squares randomly placed on the screen. Every time we refresh, they go somewhere else. You can increment your number to make more or less, and that's entirely up to you. But that will do for now. So, now we've got to get movement happening. To have our particles move, we need to update their location according to the vector. A vector is a speed and a direction, basically. In this case, we have the speed of 1 in the direction of y1. So this would be down the screen. And we do this to all the particles. So let's just do it to all the particles. Let's make a new function for doing this. And this will be our... Wait. Before that, actually, let's create an init function. Because right now, we just got bits of code running all over the place on the screen. Okay. I'll just post the whole thing. Can't copy from that thing. Hang on. Where's the chat? Press burn. Is it going to let me copy that before it fades away? Yeah. Copy. I don't have any googly pages. That'll do. Press burn. At the end of the stream, I'll probably put the entire thing somewhere. And this is HTML. Great, do a paste. And I gotta get to the Twitch. Where's Twitch at? There you go. That's everything so far for anybody who happens to be following along. I'm not expecting anybody to literally be typing as I type. I know I wouldn't be able to type that fast when watching somebody else do it. But I do ramble a lot, so I guess I'm giving you a lot of time to catch up. Anyway, so let's create an init. I like my inits to go at the top. So, function init. Our init function is the first function that's going to run that kicks everything else off. It's really cool to do this because we can now simply put init at the bottom of the page. So we tell this to run at the very end. And then all of these little sub things we've got running outside the functions can now just go within the init. So the first thing we want to do is resize our screen. The last thing we want to do is our frame offset stuff, starting the whole frame rate system. And, oh, is that everything? Well, it is right now. There's also one other thing we want to do within here, which is create our particles. So I'm also going to move that up there. So this part here, we can simply grab that. So again, this is the part that's creating our particles and putting it into the object. And we're going to put that inside of our init. So we resize the screen, then we put our particles, 100 particles, randomly throughout the screen, which we now have the size of, and then we start rendering. Okay. That looks a whole lot neater. I could also minimize stuff. I don't know if I should though, because people might be copying off things. Let's just minimize the stuff that I'm probably not going to be messing with anymore. So resize screen is pretty much done. We're not going to be touching that anymore. Rendering we're going back and forwards from, and frame offset is just rendering the frame. No, okay. So yeah, what are we doing now? Now we are... Let's get the objects to move. To get the objects to move, we want to update their locations according to the vectors. So let's make a update particle, or update object, we're calling it particles because it's particles. Update particles function. And let's actually put that before we render the frame. So we're going to update it and then render the position they're currently at instead of where they were at. Update particles function. And I'm actually going to reshuffle this a little bit. I like to keep my stuff in chronological order. So what do we have? We have our init running. This is the first thing that gets run. It resizes the screen. So let's have resize screen be at the top. Then we do the frame offset. So the frame offset function, let's move that up here. So we resize the screen, and then we do our frame offset. Frame offset updates particles, and then renders things. So let's put our updating of particles here. Function. Update our particles, and then after that is render the frame, because that goes after it. Okay, so to update our particles, we need to loop through them the same way we were in rendering. So you can just copy paste that code. We want to loop through our particles, and we want to update their locations according to the vector. So let's just say particle dot location. Let's do it one at a time. 0, 1. I like doing it this way because it doesn't break instancing. Instancing is a more advanced thing, which I have absolutely no clue how I never had a problem with this when I first started coding. But yeah, basically instancing allows you to have two things set to the same variable, and if you change one, it changes the other. And you can instance anything within an array or an object by grabbing the entire thing. It's a little bit more of a complicated thing. Way more an advanced sort of thing. I'm not going to go into that with detail, but basically I like doing it 0 and 1 because this does not break the instance. This is just habit for me. Yeah, otherwise if I just said equals an array, this would break the instance of that. Anyway, so let's just do 0 and 1. 0 is just something to keep in mind. You won't know about that if you're new to programming for a very long time. And then maybe one day you will realize that that could be something that's affecting things, and you will remember me saying something about it right now. So just a general idea that it had something to do with why I did 0 and 1s. Anyway, so particle dot vec 0. Particle vec this plus equals. So we want to get our location, and we want to add our vector to it in both axes. There we are. So this is going to be looping through all 100 particles and changing their location according to the vector. Okay, and this is how particles update. So it updates the particles and then it renders them. So we should now have particles that move down the screen. Nope, that broke. Error. Location is not defined. Where is that? 43. Yep, you are not defined. Get rid of you. Fresh. There we are. Particles moving down the screen. Hooray. Okay, so now that we have particles moving down the screen, we want to... are we up to gravity now? We want to have the vector. So now we need to have gravity. So where we're... no, we need mouse events. We want to get the location of the mouse so the particles can be pulled towards it with the gravitational pull. To do that, we need to have mouse events. Don't you do that up here? I'm used to dragging my little files across. So mouse move. I like to put my events above the init and below where I put the variables at the top of the page. So I always have global variables, mouse event or window events, and then init, and then whatever functions generally. Okay, so window.mouseMove. Window is a fun thing. If you can actually type window into the console here, and it will tell you literally everything you can do. Every single variable that's stored within the browser, like so canvas, CTX, FPS, all of that is going to be somewhere within this large amount of stuff. Let's see if we find FPS. I don't know if you guys can really see this text that well. How do alphabet? I've gone way past it, haven't I? These are all objects. Maybe I'm going to go past them. Nope, maybe I've gone well past it. Very top. Why don't I see it? Oh, interesting. FPS should have been in here. Huh. Maybe I'm just blind and oh, there it is, FPS. Yep. So FPS is there. All of these variables are there, and it'll tell you all the sorts of stuff. It's actually really fun to look through this. Really cool to look through this thing when you're just bored, I guess, seeing all the things you could do. It's got like a whole lot of API things for VR stuff, so you could do all sorts of VR things with this. Like, I don't know, USB? Like, what in the world's USB? Apparently you could do USB things? I wonder how that works. Maybe it means something different. I don't know. That would be a fun thing to look into. Maybe you could have, like, USB controllers. I know you could do something or rather with, what is it called? That connection type that you have with controllers. Like, it's not MSI or something. It's MIDI controllers. It's got a whole lot of MIDI stuff in here sometimes. I don't know. What you see depends on the browser you're using, though, and the version of the browser, and the operating system you're working on, I imagine. I'm not entirely sure, I only got the one operating system. But different browsers will tell you different stuff in there. Anyway, so we have a onMouseMove event. So whenever the mouse moves, this function will be run. And it will have an input into the function of E. E is the event, I assume that stands for. I don't know why it's E, it's just a standard thing that people use in examples. And we want this to run a mouse moved function. I'd like to have the function outside of this rather than literally putting it in here, because we need a new variable. So we need a variable to put out our stuff, and I'll get back to that. Mouse equals object. I like to have an object form. Mouse.loc and mouse.mass. We haven't gotten to mass with the particles, but I'm going to put mass here for the mouse cursor for now. That'll be the next thing to do after we get the mouse cursor stuff working, is give particles mass. So location equals just 0, 0 by default. And we need a mouse move function. So when the mouse moves, we want to run this function. And this function will say mouse.loc is equal to e. This is one of the times I don't care about instancing. which is probably a bad thing actually. I don't know. Consistency is key, as they say. E dot page X and E dot page Y. So this will tell us where on the page in the X and Y the mouse cursor is, and then we're assigning mouse location as that. So there we go. Let's show this. Yeah, let's show this off. Just see that this is working. Because probably people have had lots of problems all over the place and they don't know how to debug things. So let's try debugging. To debug, console.log is my preferred method. You can also use alerts if you want things to go step by step, but then be prepared to have many alerts. So console.log will put something into our console. Refresh that so it goes away. So we'll have text that goes into here of our own doing. So let's put mouse location in there. And let's also say mouse loc. So it'll say mouse loc equals, and then whatever this variable is. If we refresh, there we are. So whenever we move our mouse, it just used our numbers. So currently the mouse is in location X 625 and Y 100 exactly. That's nice. Yep, that's cool. That shows that is working. I won't do the alert way because that's basically just spamming the browser, but you can actually type stuff in here as well. If you say alert and then brackets, it says this. So this is what like ads and spam bot junk gets you with. It just spams that alert thing all the time. So if you say alert and then put some text in there, it says whatever the text is. There we go. So if you got something like you wanted to see every single color that every particle was, you can put an alert in here, and then it will actually stop all of your code from running until you press that OK button, in which case it will just pop up another one and another one and another one 100 times until eventually you've pressed it through all of the particles as they get spawned. So you could easily spam someone's computer with that thing. But usually browsers, depending on the browser, will have some sort of a tick box, which I think this one doesn't have for some reason, saying, do you want to keep getting messages from this site or something like that. If you click no, then alerts are disabled and they won't pop up anymore. So that's a handy thing to know. Most browsers have that, but some of them don't. Anyway, moving on. So what are we doing? We got the mouse location now. Now with the mouse location and the mouse mass, we want to have a gravitational pull towards, or the particles to have a gravitational pull towards them. But for that, we need our particles to also have mass. So I'm going to replace size with mass. You don't have to do this, you could do something else, but this is the system that I like to use. So the size of the particle will depend on its mass. The more mass it has, the bigger it will be, as generally things with mass have. You know, if they're all made out of the same material. So I'm going to call it mass, and I'm just going to keep it with 30. Okay. So this now adds a new problem, is how do I get the size from the mass? And how do I then use these two masses to get gravity? So let's just convert this to a size, because that's a nice easy thing to do when we can run that. So to do that in our rendering, where is our rendering? Bottom. So when we render, we're rendering with particle size, but we don't know what that is now. So let's just say your size. And let's define a new variable. So size is equal to, there's a formula which I've already got, which is how you work out the diameter or radius or whatever of a circle from its surface area. And that is this. So size equals the particle's mass divided by pi, and this is a really annoying thing. Math is inconsistent to how things code, and you know, consistency is key, so I don't know why they've done this inconsistently. For one thing, math has a capital M. I don't know why that happens. It should be lowercase. Maybe because it's only one word instead of two, it's capitalized. I don't know. And pi should be entirely lowercase. Or if that was true, which I said about math, it should just have a capital P. But for whatever reason, math.pi, pi, is both capitalized, and that annoys me to no end. Anyway, so we get the mass divided by pi, and then we get the square root of that. And that gives you the radius or diameter or something or other. I think it's the diameter. Yeah, that gives you the diameter of a circle, if the surface area is whatever the surface area is. Okay. Nice enough. We're not actually using circles, we're using squares. The reason behind why we're using squares and not circles, because you can use circles. After this is done, you can go Google how to do that. It's on W3 Schools, it's pretty simple. Actually, it's pretty complex, but anyway. But compared to doing a square. But it requires a whole lot more CPU power to do a circle than it does to do a square. So you won't even be able to have like a third as many particles if you're drawing them all as circles. And that's why I like doing squares. You can put more on the screen. The look is the look. You can have it as whatever you'd like. You could do other stuff as well once this is done, like maybe you have collisions. And they add their masses together when they collide to create a new particle that is bigger. And, you know, you can have like a little planetary system simulation thing if you want. Okay. So, yeah, now we have the size of the particle. We should be able to test that. We have very small particles, because that's how big it would be if it was 30. So if we say 300, that should be a whole lot bigger. Not as big as you'd expect. You'd expect it to be 300 times wider or something, but that's not how area works. There's one famous thing that people are always going on about on the internet is, yes, because you could have different masses for different particles. I'm just leaving that in as an option. That's why it's inside the loop, wherever loops went. Where am I at? Rendering, there we are. So yeah, I have that inside the loop because every particle could be different sizes. What was I saying? Yeah, if you have a medium pizza and a large pizza, there might not be much difference in size from a medium to a large in terms of radius. I mean, yeah, radius, circumference, diameter, circumference, radius. Yeah, radius, diameter, whichever one, radius, diameter. You might not see much of a difference, and it doesn't look like it's that much bigger, but because circles are circles and math is crazy, the difference between a medium and a large pizza, even though it's only a couple of dollars difference, it could be literally over twice the volume. Like, you literally get twice as much pizza for a few bucks extra. And that's just crazy. It's the same thing with drinks. Like, if you buy a drink and you have, like, the choice of a medium and a large, the medium one may look basically the same size as the large one, but in terms of volume, it can be completely different. Like, way larger than you would expect than it looks. Anyway, so that's something you probably didn't know. Or maybe did, I don't know. Okay, so now we're going to get the gravitational pull towards the mouse cursor. So our particle has mass and our cursor has mass. So we need the both to interact, and that's where we go back to the updating of particles. So we want our vector to change. Let's erase our default vector value. Also, just to show if we had 1 and 1, and refresh that, they go diagonally now. So it's 1 down and 1 across. And that's what that does. Okay, let's also change the background color from blue. It looks terrible like that, doesn't it? Let's have it black. There we are. That's a whole lot easier to see. So, what are we doing? Let me know if you want the particles to be bigger, if they're harder to see or something. I should probably just make them bigger anyway. Let's make it bigger. 300. Nice big particles. Nice, easy to see. Let's change the mass of the mouse up a bit then as well. Okay. So, we want them to have the gravitational pull. So we want to affect vector, and we want to do this before updating the location. So let's put that there. The vector 0, we don't actually know what this is going to be yet. So we want it to be affected by change. We don't know what the change is yet, though. but we want that to affect the 0 and the 1. We want it to plus equals. So now we've got to work out change. This is where things get a little bit crazy. Because I've just got to copy these functions directly because I don't understand math of this caliber entirely. I'm just going to dump those down below. Okay. So what we need to do is, the first thing we need to do is get the gravity, which is this. This is the gravity. So we need to know how much the distance, like how much pull there is between the mouse cursor and the particle. And to work that out, we get the particle's mass plus the mouse's mass, and then we divide that by the distance they are from each other. And then I got this extra bit here, so we have a stable movement regardless of what the FPS is. Okay, so we got the masses, that's fine. Now we need to get the distance. And the way we get the distance is I use this function that I call getDis. It gets the distance from one thing to another. So we want to get the distance from the particle's location to the mouse's location. And this is the getDis thing. So distance is equal to an array. Distance 0 is equal to the apps, which is... apps means instead of something being a negative number, it just simply isn't negative. So if you had -1, apps -1, it would just be 1. If you have negative apps -100, you would just have 100. So we get the x-axis minus the x-axis of one minus the x-axis of the other, and the same thing with the y, and then that's what this is. And then we square those two things together. So square of the relative x and the square of the relative y-axis is the 2. And we add those together, then we get the square root of both of those. And that magically gets us distance from one particle to the other. I don't understand how that works. I suck at math, as I say. I literally just Googled this math formula. So any complicated math you ever need to do, like how do I get a distance between two objects? Google it. There's the math. Copy, paste. Job done. You may need to convert it a bit to work in whatever you're using it from. Okay. So there you go, it's Pythagoras' theorem. So, this is great. It's like having, if I was to go back in this video and then write answers to the things I'm saying, except I don't have to because there's viewers doing it for me. Oh, so much easier. Not as if I would do that thing anyway. Anyway, so now we have the distance, so the combined masses divided by the distance, and then we're dividing by the FPS to give us a stable change. Because without that divided by FPS, this will be running every single frame. If we were to double our frame rate, we would then also be doubling the speed at which everything moves. So it's not so bad, like if you're planning on changing your frame rate, so you could literally just change your frame rate if you want things to move faster. But there are some problems with that. Problems which I probably should have gone on about earlier, but I didn't because of reasons. The blur we have. The blur that we have is coming back out the back of stuff. If we had these particles moving too fast, you would literally see a square there, a square here, a square there, with like a big gap between them. So to make the gaps between each of those stamps shorter, you would increase the frame rate. If you double the frame rate, there will be half the distance between the gaps, and so on. But if you didn't do this, then it would be the same distance between the gaps, but the particle would just be moving a whole lot further over time. So by doing this, we can now adjust our frame rate to create more steps in the motion blur. There you go. Fancy, simple solution for what could be a complex problem. You could also do crazier stuff, like you could literally draw a shape between where it was and where it is to get smoother blurs, but I'm not going to get into that. That's much, much more complicated. Okay. So, yeah, that's that. Now we have the change that will be affected between the two things. So really this should probably be ×2, because one of them staying still, so all of the effect is happening to just the particle. But I don't care. You don't notice any difference. It still looks pretty good. So, just conservation of energy. Is that the right word? Doesn't sound right. Yes, that is entirely true, which is actually why I do like using this system. Wherever that's a bit 2 frame offset. So this set timeout doesn't start its timer until all code has finished running. And although you might not think it, code takes time to run. It doesn't matter what it is, if it's doing something, it's gonna take time. The amount of time is just basically so insignificant that you don't care about it, generally, and that's why some people think that it doesn't take any time, but it always does take time. So if you wanted to have a true, not entirely correct, but generally correct frame rate, you will have to account for that. And there's different ways you can do that. One of them is by, I don't know what the function is off the top of my head, but there is a function you can call that gets the system time, or the system time at the time that function had run. So down to the millisecond. There's another one that just gets it down to the second, which was a real pain when I first started coding because I didn't know about the millisecond one. So I used to get what the frame was, what the time was every single frame for, say, like 50 frames, and then I would average them together to get basically the milliseconds. Yeah, performance now, that's what it is. The delta time. So basically you can get the time at the very beginning of your code. So all of our code starts here. So start. You can't have an interval of 0, as I was explaining earlier. The set timeout can only go as low as around about 10 milliseconds, depending on your browser, depending on your operating system, depending on the alignment of the stars. I don't know. Different things do different stuff. You can Google it to find out more information about that, which one is good. Yeah. What? Yeah, so what I do is all of the code that we're running every frame starts here, and, well, actually ends down here. So all of the code we're running per frame is that. So if we get the performance now thing at the start and the performance now thing at the end, and then we just minus the start to the end, we will have approximately exactly how long our code took to run in milliseconds. So we could simply minus that from here. There you go. Because it hasn't started the set timeout. It hasn't started counting until this part is run and all that other code is finished. So there are some pieces of code that will also run at the end of all that code. Say the rendering possibly runs after all that code, but I'm not entirely sure about that. It might be rendering but not updating the literal display on the screen, and maybe that's why it doesn't display. I don't know, I haven't done the research into it. Stuff like loading an image, if you were to load an image from your server, that takes time that is outside of the code. Or saving the canvas as an image, that takes time outside the code. I don't know, lots of examples around the place. But this system doesn't take that into account. And I have spent many, many literal months on my frame rate system trying to get it perfect, and it never is. But yeah, that's how you'll take that into account. And that's why I like set timeout more than I like the set interval stuff, because we could have a generally stable frame rate of it running basically exactly when we want it to, instead of at every possible moment, which just brings your computer to its basically knees. Because, yeah, you don't need to be running at 100% performance to show particles on the screen. I mean, this doesn't require 100% of your browser performance, so that's just lazy doing it that way. It works, but it's lazy. Anyway, so yeah, now that we have the change, we needed to affect the vector. So we need to know what direction this change is going to happen in. That's the next thing, which is why I have this neat function here called getRot. Gets the rotation from one thing to another. I can't say from because from is a special word, so I say at to. So at this location to that location, what would the rotation be? And that's how that works. And this gives it back, this part at the end here, because this gives it to you as a radian. A radian is basically degrees, but in a different unit system. Degrees go from 0 to 360, or whatever. And a radian goes from 0 to 2 times pi. So this converts it from radians to degrees, this bit at the end. So this will return in degrees the rotation from one object to another. Rot equals get rot. Let's say rotation. I probably spelled that wrong, didn't I? Did I say rotation the other one? No, I said direction. I can sort of spell direction. Direction. Alright, yeah, there'll be a copy of this on YouTube if you want to rewatch it or something. Thanks for dropping by. So, yeah, direction we want to know from one to another, so we can literally just copy paste these two locations. So this is just the XY of one and XY of the other. And these, they have inputs of two arrays, an array of two things for both of them, for the out and the two. Okay, so now we've got the change, we've got the direction. So now we need to convert the change with the direction into a vector to have that vector then added to our current vector to then affect the location. And to do that, I have this neat function here called change distance. These functions are really, really old. I basically created these like on day one of programming, and I have been copying these around ever since for like the last 5 years between different languages and everything. They've been to C, they've been to Python. These functions are very key. You will use these all the time. I don't really know a single project I'd ever do that does not use these functions. Just to let people know, these are very important. And you only need to do them once. I don't understand how they work, I just got them and use them. You just need to know what they do. So that's why math is somewhat irrelevant when it comes to programming. You just need to know logic, basically. Although it would be nice if I did understand how these worked, but I can program a 3D game engine perfectly fine without understanding it. And I literally just use these. I don't use anything else anything like this. I never use signs or anything like that outside of here. Except for one thing, which I don't remember right now. I'm pretty sure I've got at least one function around. Anyway, so let's say so our vector, which is a combination of the change in direction, will be output from here. Yeah, so we have our change and we have our direction. So this will, like, it's called change distance because you can think about it like you have one object and you have another object. They're in two different locations. And you want to change the location of one object to be closer to the other one. Where would its new location be? And that's what this does. And that's what a vector is, basically. So, yeah. We have the distance and the direction we want to move towards. And that will output an XY vector. So you could then get this and plus it to the location to change the distance by however much. I'm pretty new to WebGL. I'm still doing the one project that I... what? Line what? 89. Okay. That would be nice, but I'm not going to remember that right now and I'll add it in, because this is... if I change that here, I'd have to change it on all of my code, because that's actually a good thing to do. I'll go back through the comments later on and update things like that. But let's get it working before I do any changes that could break stuff. What was I saying? Oh yeah. I'm pretty new to WebGL. I've only done one project in it so far, which is the current one that I'm working on that isn't this, which is my Doom project. I stream that pretty much every day. Anybody wanted to come by, watch that. Yeah, I don't like radians. I like degrees. But yeah, okay. I was saying, yeah, so I don't think I'm experienced enough with WebGL to be able to do much yet. I am building my system for that. The next project I'll be getting that down, so probably after then I might do something like this if people like it. Apparently I've got 10 viewers, but my chat is wrong. the number of viewers I have is incorrect. When people join or leave too quickly, sometimes it doesn't realize they left. But anyway, if people didn't like this, which is terrible saying this midway through, but feel free to donate and stuff, and I will be sure to continue doing projects like this. I have a somewhat large lineup of things like this that I would like to do if people were interested. You can show your interest by donating. $10 feeds me for a day. Anyway, shameless plug. There's a donate button in the description if you scroll down. So, okay, so we got the vector. With that vector, which I called change for whatever reason here, we could just put that in there. There we go. So now we are adding to our vector by the change that is affected by the gravitational pull between the particle and the cursor. Well, there we go. They are flying towards wherever the cursor is. Let's get one to like stop. Okay, pull back. It's hard to tell where it's going. I've done something wrong with the sizes, I just realized. The center of the box is at the top right, or the top left. So I need to offset that, but hey, there we go. We've got the gravitational pull going towards the mouse cursor. Which a fun thing we can do is where rendering is, down the bottom. Let's change that to a 0. I just put the mouse cursor there. So now we can see the entire path that each one of them took. So, yeah, if you wanted to experiment around with stuff, you could add that. Is my thing moving down? That was weird. You could add that to. You could add the alpha to a variable, and have it adjust over time or something like that. So you could make it so you could see the path if you toggle the button or something. But I'm not going to get into keyboard inputs and stuff like that on this particular thing. Yeah, let's continue on before I go on about next possible stuff. So what's next? Let's turn that back on to 0.3. The middle of the particles aren't entirely correct right now, so let's say that minus half of the size. And now the middle of the particle, or the origin point of the particle, or whatever you want to call it. Median point, origin point, center of mass, center of mass, I don't know. That'll be in the middle of the particle. Nice and simple like that. And let's also add a few more particles. Particles. Okay. Is that actually everything? I don't know. Is there anything else we could do with this? I guess I could just go on about stuff you could do with it. Hang on, I've missed stuff, haven't I? Things I've forgotten is we have colors. Our particles have colors, which aren't being added into here. We are setting them all to be the same color by... Yeah, I could do that. So, let's just add a little bit extra, just because I can. It's extra stream time. Let's have our particle colors go from the particle's color variable itself by saying we're moving this, putting quotation marks and pluses in here. Then we say particle dot color dot to string. So this gets our array of our particle color, and it turns it into a string, which is pretty funny because the array as a string is just literally that. So it just literally puts strings around our arrays. So that's actually pretty cool. And except without the square brackets. So this is basically what this returns, which is pretty much what we had there already. So we can literally just dump it through like that. Job done. Let's also add a background color, so we don't have to scroll down here to change the alpha. Background color dot to string. This is a function, the toString thing. You got to remember the bit at the end, otherwise it won't work. It'll tell you an error, but so often I forget to do that. Okay, so background color Now we can just change that up here without having to scroll up and down all the time. Generally, we have it so everything we want to change when messing around with stuff is a variable up here. It's just a cool thing to do. But I'm not doing that with stuff in here because we could have this stuff happening dynamically. Say if we had a random. So let's give it random mass. Let's just check to see if everything's working right now. Okay. Yep. So that seems to be fine. If we change the color, it changes color. Great. Okay, so I like the red. Let's make a random mass by saying math.random times 300. So this will have a random mass between basically 0 and 300, which is terrible. We don't want that. Because if it was near 0, the dot would be too small to see. Let's see what it looks like anyway. So there, we got this real mess. It seems like the bigger ones are getting pulled in faster. Is that how gravity works? I don't know. I feel like there's something wrong there. That's like the... No, that's right. Yeah, there's more of it to be affected by the gravity, so it would be pulled in faster. Sure, let's say that's true. Let's offset this. So let's grab that and say plus 300. So it'll be from the size, let's probably not go that high. Let's say 100, no, let's say 300. So the smallest one will be 300, the largest one will be about 400. I mean, the smallest one is 100, the largest one is about 400. Did I say that? I don't know. There you go, random things. Let's get our color to be affected by that. So knowing what our max minimum thing is, let's say mass minus 100. So now it's from 0 to 300. Oops. Divided by 300 times 255. So that makes our mass between 0 and 300. We divide by 300 to make it between 0 and 1, and then we times by 255 to make it between 0 and 255. That's that. Let's make it a little bit more pretty by add some purple in there. Let's grab this. Okay. That's more difficult though. I'm just going to do a simple color thing. So that 255 minus that. So this is from 0 to 255, and we minus that from 255 to make an inverted color. So if this one's 100% red, this one will be 0% blue. If it's 0% red, it'll be 100% blue. And that just looks like a rainbow mess, doesn't it? Or a gradient mess. But yeah, you can see the little blue ones falling behind at the back. That's pretty cool. Okay. That's the thing. I feel like my frame rate's going a bit slow. I'm going to lower my particles and up the frame rate. Oh, that's much smoother. That probably looks terrible for you guys now because it's moving too fast. I feel like my motion blur is too strong too. Let's lower that down. That will give it trails, but whatever. Oh, it didn't give it trails. Oh. Yep. Alright, so you can mess around with your colors in different ways. So instead of doing that, we could be using the vector. But if you were to use the vector to affect the color, you'll have to be changing the color when we update the vector information. So down here, after we update the vector, whatever, let's do it. Let's do the same thing. The problem with that is we don't know the minimum and maximum that the color can be when with a vector. So let's say particle vector 0. Particle vector 0. We don't need to do the minus 100 part. And sure, let's offset by 300. I'm not entirely sure what numbers the vectors are at any time. Did I remove something? Nope, that's fine. Everything's blue. We broke it. Data. Because you're a particle color, not data color. Uh-huh. So it's just always blue. I don't think that would be greater than 300. Wonder what it would be. So we get the vector divided by blue. Blue would mean this is a 0, so this is too much. Let's say 50. Nope. 10? Unless something else is going wrong with math. As I say, I'm terrible with math. Nope. Oh, wait, yes. Okay, we've got some color changes now. Okay, 5. Because my frame rate is so high, they're moving quite fast. There we are. Yeah, that's why I wanted it to be. Oh yes, it's only the left and right movement that would be affecting it. So let's get that and plus by the other one. So that plus the other one. All of you. Probably all of you in brackets, that'd be easier. And put that there. Okay, the added thing of both vectors. There we are. That looks a bit nicer. So there you go, you can mess around with stuff like that. The one that I've done before, or previously or whatever, it has a... Oh, I see what you mean. It's only when it goes down in one direction that it's happening. I need to apps it. Math apps. And math apps. There we go. Is it? Did that not work? There we are. Okay. So yeah, feel free to mess around with it all you want. I think I'm pretty much gonna say that's that. Otherwise, I could be messing around with this thing for weeks. Okay. Yeah, you could do that. That would be okay. Let's do that. So that's change. Change is just a single value, so let's just dump through change. I don't know what change is up to. Let's lower the FPS so these numbers are a bit bigger. 24. How can I find out what this number is? I could just log all of them, but that'd be a pain. Let's just get one of them. Log particles 0. Yeah, I'll just do this. Particles 0 dot... Oh, I don't know what that one... Okay, I'll have to do that. And you should actually know what particles is, shouldn't you? I should just be able to say particle, which should still be the last one that went through. So what does change? Okay, so you're a fairly small number. Where are you? This should be changing depending on the distance, right? I don't know. I think what your point was to get the distance, wasn't it? No, I haven't finished with the Doom project. Oh yeah. Divided by the FPS. No, it seems to just be a big number. Interesting. What? Oh. Okay, that's weird. What am I doing? 0, 0 particle. That would just be to 0. Maybe this isn't right. Hang on. Let's just say this 0. Let's get the first thing in the index. I didn't pre-do this stuff before, so... Interesting. What is going on here? Particle 0 location. What are you? Well, you're going to be a different place every time. And then you're moving. But it is a number. And the mouse location should be the mouse location. So why doesn't my distance seem to be affected by that? I can't really get that to go down by any sort of amount. Weird. What am I missing here? Oh, welcome to the wonderful world of programming. Anyway, yeah, I'll leave that to anybody who wanted to mess around to do that. Yeah, so... end of stream rant. What should I rant about? Feel free to donate. Well, 0 would be just to 0... Oh. Wait, hang on. Right. To the mouse cursor? Yeah, that's just 0. The mouse location is not updating correctly? But... yeah, something weird's going on here. Yeah, well, I gotta get this number to be a number first. So it's just the mouse location, getting the distance from 0, 0 to mouse location. But it's not getting the distance. Yeah, wonderful world of programming. Okay. Yeah, look at that. Huh. Drop that in there directly. Yeah, yeah. That happens. Huh. Probably makes me look pretty bad at it's happening, but it's probably something real obvious. I'm not messing with add or to. There's no instancing error. Distance is defined within the getDis gets the distance between two locations. So this should be returning 100. Yeah. No? Weird. What about this one? That one works. Yeah. But it's the same code. I mean, if it was wrong for that, it should be wrong for everything. But it does definitely look like it's pulling the things towards the mouse cursor. Seeing as I could get one to stop and stuff. There we are. Well, there. Whatever. That still work without the apps? Oh, okay. But it wasn't a problem with the other one. Yeah, it still says 0. One? Okay. So, I mean, at. That's the problem. I don't know how this was working in the first place. Classic programming. There we are. That was crazy. Wow. I don't know what to think about that. That looks a lot nicer though. Yeah, I was thinking that the gravity felt a little off. So yeah, the color is depending on the distance to the mouse cursor now. Well, that sucks. I'll have to add like a note on the stream then, on the recording of this, that was wrong. Yeah, because I messed with this before. I did this before I started streaming. I just typed out the whole thing, which took about 15 minutes to do this whole thing without rambling on about it. Who knows how long this has been so far. It's been 2 hours. Whatever. Yeah, weird. I didn't know you didn't need the apps though. Unless you do need the apps, and now that won't work? I don't know. Whatever. Things are moving way too fast. So let's turn down the mouse a bit. This thing's getting flung off. Slingshot orbits. Yeah. Which is a nice easy thing to do, because I left the code there. Let's remove that one. Oh wait, that's based on, that's not speed, that's mass. Change. Oh damn it, I gotta put it all back in again. Vec 0 plus vec 1. Whoa. Okay, that's weird. Because I gotta apps both of them, don't I? I'm adding it in before I apps it, so it does little weird things. Whatever. It's just the diagonal that it's affecting. So remove that, put that in here. That's the fun of this particle thing. You guys can mess around with this. The cows come home, as they say. There's no end to the amount of things you can do with it. That's the fun of coding. Probably. Oh yeah, that was the flat plane one with WebGL. There we are. That looks nicer. Or the wavy plane. So let's put this all the way down. Let's have like 50 to 50. It just slingshots out at extreme speeds. So that's one thing that people could mess around with this thing is, what? Oh yeah, the distance thing. So let's just duplicate that. And you would be by change. All of that by change. And oh, I left the apps on that one. All of that by change. Oh yes, it would be, wouldn't it? Oh yeah. And let's lower the number. Whatever. Make it even lower than that. There we are. Why is this? Oh yeah, because the motion blur isn't live, so it has like the motion blur of when it was red. Yep. Yeah, but as I said, like the actual one that I made years ago, this one has way more fancy math behind it, which I have no clue how I did. I just messed with stuff till it worked. Such as, wow, it seems like it's running faster now. That's weird. It reminds me of like grass. Like you see those hilltops of the grass that I call teddy bear grass because it's like fluffy, like grass, and it just like sways around in the wind. It's like that mixed with like seaweed on the ground or something. Yeah. Yeah, my one has like a whole lot of crazy stuff to stop it from slingshotting off at crazy high speeds into the distance, and also like a browning effect to slow it down. So it won't, like, you can slingshots off things off the screen at super high speeds, but the stream, the making of this, I don't think so. If you mean the other guy's thing, I always have this thing on my stream. Whenever I go AFK or something for a while, I just put this on so you just watch it. But yeah, it's got a fancy math in it that makes it so it doesn't slingshot off the screen at super high speed, so then it may only appear for a second and you'll never really slow it down because it's just always moving too quickly. Take a very long time to slow down. And then it's also got a thing to stop it from collapsing to a single point. So if you leave the mouse here for, I've left the mouse here for over half an hour and it still won't be collapsed down to a single pixel. So I could always just flick the mouse to the side and it just springs back out again. Yeah. Yeah, you're the guy with the wobbly wave one? Is that what you're talking about? Let me just find that. Yeah, wobbly wave. Woo. My stream has been hijacked. Anyway, so if people like this tutorial stream sort of thing, as I said, it'd be nice if we got a donation. There'll be a copy of it on the YouTubes. And, oh god. I did terrible things. Why are there ads playing? Pastebin's got ads that just started playing. Yeah, so, what was I saying? Yeah, if people like this, I'll do more. Other ones that I could do later on is a more complicated thing of this. Which, this one, it'll take probably an extra hour longer to do. What did you do? What did you say? What? Speed. Oh, color. Speed. Speed equals what? Get distance 0. The speed? Are you sure of the speed? Yeah. Okay. So, check that out. Wait, for speed. For the vector. But that's distance. Distance is just a single number. What would be the other number? Distance is an int. You mean then pass it through the change? It's so laggy. And I'm half asleep. What about get distance 0 particle vector? So I just... Okay. Where's the get distance? No, it wants me to change the vector? Do you mean of the original one or of this one? Well, you said particle vec, so... Yeah, that doesn't make sense to me. I don't know what it's going to do. That there and this there. So that's what you want? This is just going to go on a diagonal line. And 71. Speed isn't a thing though. Very cool. Okay. So you do want me to change the color. Speed equals that. So what numbers are you expecting to get out of this thing? Let's just type in 50. Well, it's blue, so it probably just means it's too fast. Let's try 10. There we are. So yeah, it's just the speed. I don't get it. Okay. Oh yeah, I guess that's a different way of doing the same thing that I was doing. I just apps the vectors and add them together. But I guess that's not right, is it? Is it? Yeah, it would be right. Okay. Well, the vectors are the speed divided into whatever the x and y change would be. So if you add it back together, that would give you the speed. And I was doing it change of speed, except it's divided by the FPS. But it's still change, so this should basically look the same as if I just said change. Oh, we had one that was moving really fast. This number is just a lower number. Oh, never mind. Change is the current. Ah, never mind. Yeah. So change is the current change, not the added thing over time. Where that speed is over time, which is just the particle vector, and this is done in basically the same way as if I just said the vector x and y added together, apps to one of the other added together. Well, I mean, like, if I use this change distance thing, I think that should work. So if I say change distance, the direction is just 0, and the change is 1. It's -1. Okay, sure, whatever. Yeah, it's the same. Yeah. So if you just apps that, it would be 100. If I put it diagonally, 45. Okay. 90? Yeah. So 45 should be diagonal. Okay, never mind. What? Why is it 70-70? So you can't add those up to get 100? You'd add them up to get 0. And if you apps them both, whatever. Okay, so that's wrong. Wow, okay. I'm pretty sure that's the way I've been doing that. I'm very confused now. Okay. That's the hell. Weird. I really don't think that's the way I would have done it in my original one, but there it is. Yep, okay. Well, anyway, back to the ending of this thing. So feel free to donate again. If anybody, that's right. I was showing the. Everybody probably would have left by now who hadn't already. But if people want me to continue doing this, please don't distract me again, so I can leave. This is the other thing I wanted to do, but this thing would have taken a couple of hours longer than this one. So you got a mouse. It's the same mouse location and updating of vectors, except this one has collisions. And it also has inputs. So I press spacebar to shoot particles. It's also got it so when there's too many particles, it will delete the older ones, so it replaces them with newer ones. And each one's just getting a random color. So there you go. So this one teaches you collisions and also keyboard events. That's just a more complex one. If I was going to do that, I'll try to do it in a much more structured way than this one. This one's just a test, I guess. Although if a test isn't to its full potential, then that I could do at the time, what's the point of it? But I guess if people like this, then hopefully you'd like this one even better, I guess is the idea. Yeah, after that, I could do something like Snake, or I could do Pong. Snake would be a grid-based thing. So you'll be moving tile to tile, and that will teach you all about grid-based stuff. And Pong is a more global thing. Actually, Pong is not much more different to this, really. So I probably wouldn't do Pong if I did this one. But Pong is a game. And this is just a fun little simulation thing. I think that Pong would be more cooler than this in terms of programming it, but this one looks prettier. Okay. Well, I have a Facebook group in the description. I'll be linking on the YouTube things as well. I'll have probably two on the YouTube one, where for indie game, I mean, what is it, not indie game dev? What do you call it? JavaScript game developers. I created a group called JavaScript game developers for people who like building stuff entirely from scratch, or their own stuff in JavaScript, or just stuff in general using JavaScript. And my other group is Fifth Function, which is what I call myself, and there I'll be posting updates on anything that I do. So if people want something like this, and I'm going to do something like this again, then you can just add yourself to that group, I guess. I'll probably create another group, especially for the live stream ones, the tutorial live stream things, but yeah, I created one that was a page. I think it should be a group rather than a page. I don't like pages that much. Nobody seemed to actually see it. But yeah, future projects is Snake, Pong, a side-scroller, or possibly even a top-down shooter, which would be more complicated things. I could also do something like make a card game. I've got like flowcharts and stuff around the place for card games I've made in the past. On my YouTube, I've got a tutorial for one, making it in Blender, if you could call it a tutorial. I don't even know if this should be called a tutorial, because it's just sort of me rambling. I guess it would be better when I get more viewers and people on chat, but then it's going to take longer as well, and probably be more boring to watch, possibly. Who knows? I don't know. I ramble a lot. I'll try to do less in these sort of things. Other than that, I try to stream every single day, so if anyone just wanted to watch random streams, then add yourself to my Twitch, I guess. I think you get email notifications. Yeah, if anybody has any suggestions of things they wanted to learn, if live streaming tutorial things are a thing that people like, I guess I'll have a suggestion thing in the group that I create. I'll add that probably after this, so if people are there especially for this stuff, then you can add yourself to the group. And there's enough people, I'll do more, I guess. There's enough interest. Yeah. Well, it's just trying to figure out something that's simple and breaking things down. I mean, another thing I could do is, like, stuff in steps. So, say, like, I could create something in the form of a particle simulation, sort of thing like I've done here. Except with keyboard inputs, which is basically this one. And then I could literally convert this code into a side-scrolling game. like a platformer, side-scrolling platformer. I mean, you have keyboard inputs, you have movements, vectors, gravity, collisions. Right now, the collisions in this one are literally boxes outside of the screen that they bounce off of, and then they land on the one on the ground. So you could literally have just a particle that's a plane with a texture as a character on it, and you'll be able to change his vector to make him walk left and right. You could have collisions of stuff, stage level things, you can jump up and down on it and stuff. And more particles, you can make him shoot stuff. If the particle hits something, then do damage. I will be using plain JavaScript, that's what I do. I don't use libraries at all. All my code is entirely built from scratch by me, generally. As much as I can get away with. Basically all of it. I mean, I didn't technically work out how to do these functions, because that's beyond my math level, but I did type them and convert them and make them my own. They are completely different to how they looked in the stuff that I copied from. But everything else pretty much is my own stuff, from the ground up. I'm pretty sure literally everything else other than this. Which, yeah, I've got very large amounts of stuff. This is my functions file. This is where I store all my functions. It's many lines long. I have everything here from 3D game engines, 2D game engines, everything. All the many, many lines. My whole viewport system. But yeah, I could do like one on pathfinding, I guess. Although my Pathfinder really needs to be optimized now. I wonder where that's even at. It probably looks like garbage to anybody else, but it works. You can see stuff on my website which uses it for examples. Pathfinder, there it is. Yeah, well, this is basically my library. Which the majority of this code is my Pathfinder. Oh wait, that's actually that many lines code. I thought it was more. But yeah, I don't watch tutorials or anything like that as well. I code all of my own stuff from scratch, however I think it should be done. This is what I come out with. I think this is called A-star pathfinding or something like that, people tell me. But yeah, that would be a day on its own just to go through all that. And it would have to be built from something else, so after the Snake project or something like that. Say, to build an AI to play Snake. It could be using the Pathfinder. So that could be a separate project after the Snake one. I don't know. But yeah. So I guess I don't know how I would do suggestions on my group though for that stuff. I guess people could just post about it and I'll add it to a list. Yeah. Although, again, I guess maybe as I do more, maybe I'll get better and faster, so I can do it in less than 2 hours. Because 2 hours is way too long. It shouldn't even be an hour. Like, yeah. But then the more people watch, the more comments I'll have. Yeah. Wait. Have I ever made Snake before? Oh my god, I don't think I've ever actually made Snake before. Wow. It's like my most go-to thing for tutorials when I'm teaching people, yet nobody's actually stayed around long enough for me to finish it, so I've never actually finished building Snake before. Oh, that's hilarious. That'll be a fun one to do. I don't know. But anyway, there we go. That's this thing. Let me put it up online. Wherever that thing went. Nope, the other one. Make a new one. Yeah. HTML. There you go. So if anybody was here long enough and still here and wanted the code, finished code, for whatever reasons, here you go. Wherever I find the stream. Okay, I can't see stuff at the moment. Oh. That's on the... Damn it. Copy. Damn it! Stay still. Copy. Yep. You can sleep now. Oh, it's a zip. I thought it was hosted here or something like that. I'm gonna go now. I'm tired as well and hungry. And I really need to have a shower. But anyway. So, yeah, I guess thanks for watching. Don't forget to like, favorite, subscribe, donate, share, all that sort of stuff. Links in the description for my Facebook. And in a minute I should have a post there for a new group, especially for this stuff, if people have interest in it. There's also a copy of this on the YouTubes. Or at least there should be. I'm pretty sure I turned it on, so there was. Otherwise I'll have to upload this whole thing to the YouTubes. Yeah, there we go. So I think I'm gonna go now.